The breathalyzer test relies on a redox reaction between ethanol and dichromate ions. Dichromate ions in solution give an orangish-red color, but once reacted with ethanol in an acidic solution, the freed chromium-3 ions have a green color. Balance the breathalyzer reaction using the half reaction method. So first off, you separate out your two halves, the oxidation half and the reduction half. If you look at the oxidation states of each of these elements, you'll find that it is the alcohol that gets oxidized and the dichromate, which is reduced. And so we'll write that out. And the dichromate there we go. So step one then is to balance everything that isn't hydrogen or oxygen. So in the oxidation half, we have carbon is the only thing that isn't oxygen or hydrogen, and in the first half we have 2 carbons, and in the other one we have 2 carbons, so everything's fine there. In the reduction half, we see that we have chromium, and there's 2 in the reactant side, and so we need to put a 2 in front of the chromium-3 ion so that we balance those out. Next, we look at the oxygen. So in the oxidation half, there's 1 oxygen on the reactant side, but there's 2 on the product side, and so we need to add a water to the reactant side so that we balance out our oxygens. In the reduction half, we have 7 oxygens on the reactant side and none on the product side, so we need to add 7 waters to the product side to balance out the oxygens there. Next is the hydrogens. In the oxidation half, we have 2 plus 5 more is 7 plus 1 more is 8 hydrogens on the reactant side and only 4 on the product side, so we need to add 4 H pluses there. In the reduction half, we have no hydrogens on the reactant side, yet we have 14 on the product side, so we need to add 14 H pluses there. Now we have all of our elements balanced out. We need to look at how many electrons we need to add to balance out the charges. Remember that in the oxidation half, the electrons should always need to be added to the product side, and in the reduction half, the electrons should always be added to the reactant side. So if you're not doing that, there's something wrong with what you've done, and go back and check your balancing. So in the oxidation half, the reactant side has an overall charge of 0. None of those things are charged, neither water nor alcohol. But on the product side, we see we have an overall charge of plus 4. So to bring that down to 0, we need to add 4 electrons. On the reduction half, we have an overall charge of plus 14 minus 2 on the reactant side, so that's a charge of plus 12. And on the product side, we have 2 chromium-3s, so that gives us an overall charge of plus 6. So we need to add 6 electrons to the reactant side so that we balance out the charges again. Next thing we need to do is make sure that our electrons are equal. So 4 electrons being produced in the oxidation half, and then 6 electrons being used up in the reduction half. That can't be, since it's all the same electrons, one leaving some compounds and then going to the other. They have to be the same number. So again, think about lowest common denominator here. How can you make 6 and 4 the same? Well, if you multiply everything by 3 and everything by 2, you'll have 12 there. So let's do that. So that gives me 3 H2Os plus 3 alcohols. They make 3 acetic acids plus 12 H pluses plus 12 electrons. In the reduction half, we're going to multiply everything by 2 so that we have 12 electrons. So that starts off 12 electrons plus now 28 H pluses plus 2 dichromates. And they'll make 4 chromium-3s and 14 waters. Now we're at the stage, since everything's balanced out, we have the right charges, right numbers of everything, and an equal number of electrons in both half reactions. We combine all of their reactant sides together and all of the product sides together. And that's going to give us a big, long equation, which we can then cancel some things out. So first off, again, the order doesn't matter as long as all the reactants are on the reactant side and all the products are on the product side. 3 H2Os plus 3 alcohols plus 12 electrons plus 28 H pluses plus 2 dichromates make 3 acetic acids plus 12 H pluses, and I'll just write the rest of them down here, plus 12 electrons plus 4 chromium 3s plus 14 H2Os. Last step then is to cancel out everything that's the same on both sides, just like you do in math class. And like I said before, the electrons should always cancel. You should always have the same number of both on each side so that they disappear. But in this example, we have waters and H pluses on both sides. So in this case, I have 3 waters on the reactant side and 14 waters on the product side. So I can get rid of my 3 on the reactant side and change 14 down to 11 since we got rid of 3. Same thing with the H pluses. I have 28 on the reactant side and only 12 on the product side. So if I get rid of all 12 on the product side, I can get rid of 12 on the reactant side, which leaves me with 16. And so my final answer then is 3 C2H5 OHs plus 16 H pluses plus 2 dichromates, and that makes 3 acetic acids plus 4 chromium 3s plus 11 H2Os. And there's your final answer.